Okay, am I live? Am I audible?
Yes,
Yes,
sir.
sir.
Yes. Okay. So, welcome all to this live by Pathfinder Education Services. And as always, we try to solve questions based on one particular topic. Today, that is Friday live, and tomorrow, that is Saturday live, we'll be focusing our attention on old questions of CAT or CAT level questions. Let's not waste any more time and just get straight away into the questions. The modus operandi will be same. I'll present to you the first questions. I'll give you 2 to 3 minutes to solve each question. And then, I'll show you how to solve if you're not able to solve the question. Let us get started with the first one. So this is the first question for you. Your time starts now. Okay, HK, can you just rename yourself? It'll be great if I can know your name. That's all. Someone has entered with initials HK. You can just rename yourself. It'll be great. Prachi says 200. Any other answers? Any other answers? Okay, Anushka, Atharva, anybody else who's got any answer? Okay.
No, sir.
So let us see how to approach this question. Somebody was saying something, please. Atharva, you wanted to say something?
No, sir, haven't got the answer.
Okay, fine. Doesn't matter. See, in a chess competition, some boys and girls of a school, every student had to play exactly one game with every other student. It was found that 45 games were played where both the players were girls. Now see, the first thing that you need to know is if there are n girls and each girl plays with every other girls, then the number of games will be NC2, right? N choose 2. And this is given to be equal to 45. How is this NC2? Because we have to make pairs of people, all possible pairs out of n girls. So all possible pairs of 2 girls out of n girls will be equal to NC2. That is why NC2 is equal to 45. So what do you get? N factorial upon 2 factorial into n minus 2 factorial must be equal to 45. And this cancels as n into n minus 1 upon 2 is equal to 45. So n into n minus 1 is equal to 90. You can simply see that n must be equal to 10. You can just fit in these values or solve the quadratic equation, but fitting the values as 10 and 9 is much easier here. So you know that now there are 10 girls. What about boys? In 190 games, both the players were boys. So if there are m boys, again, there must be MC2 games, correct? If there are MC2 games, it implies MC2 must be equal to 190. Because again, all possible pairs of two players must be involved. So we have m factorial upon 2 factorial into m minus 2 factorial. This is equal to 190. Which means if you simplify this, you'll get m into m minus 1. I'm sorry. M into m minus 1 as 190. And again, sorry, not 190, but 380. And again, you can simply see that m must be equal to 20. By observation, you can find out, or you can just solve this quadratic equation. So you have the number of girls as 10 and you have the number of boys as 20. Now, how many matches will be played where one girl and one boy is involved? 10 into 20, that is 200. So your answer simply must be equal to 200. Are you clear, all of you? If you're clear, let me know. If you have any
Yes,
doubts,
sir.
please feel free to ask. Yeah. Next. And we have the next question. And this question is actually an old CAT question. I think CAT 2002 or 2003, this question was asked. And this concept has been asked in the last, 15, 20 years. I have seen a question based on this concept asked around 3 times. Okay. Next question. And your time starts now. Those of you who are here for the first time on YouTube, please be aware that Pathfinder Lives are there every Friday and every Saturday. And we generally focus on one particular topic. And we try to solve questions which are of CAT level or old CAT questions. That's what we try to do. So you can solve question number 2. Let's see how many of you are able to attack this question. Okay, so both that was quick, I must say, and you'll have to just wait for me to give you an answer. Prachi says D. Anybody else who has got an answer? So there are 2 people who've got the same answer. Okay, Atharv also says D. Okay, last 20 seconds and then I'll start solving the question. Again, it's an old CAT question. And we have started solving with old CAT questions. And as we progress into the season, we'll start solving questions from CAT in the past 5-7 years. Okay. So I guess 2 people got the answer, and the correct answer is indeed 728. Now, the first thing you've got to understand here is there are only 3 digits, 0, 7, and 8. And you want numbers that are greater than 0 and less than a million. So these numbers can be single digit numbers or 2-digit numbers or 3-digit numbers, because all single 2, 3, 4-digit, 5-digit numbers will be, and even 6-digit numbers will be less than a million. A million is 10 lakhs, which has 7 digits. So we want to find out how many numbers can be made which have 1 digit or 2 digits or 3 digits or 4 or 5 or 6 digits. That's what we want to find out. And these are all OR cases. And we all know that in mathematics, OR is replaced by a plus sign. So how many single digit numbers can be made? If it's a single digit number, I can't have a 0. So only 2 single digit numbers can be made. What about 2-digit numbers? Now we'll have to calculate here. A 2-digit numbers will have a tens place and a units place. You cannot have 0 on the tens place. So tens place can be filled in 2 ways. The units place can be filled in 3 ways. And the total number of numbers which are of 2 digits will be 6. Similarly, how many 3-digit numbers will we have? And let us quickly calculate the number of 3-digit numbers. So we have 1, 2, and 3 digits. The first place, that is the hundreds place, cannot have 0. So I can fill it in 2 ways. And the remaining 2 positions I can fill in 3 ways. So 3 into 3, 9, 2s are 18. So there are 18 3-digit numbers. How many 4-digit numbers? By the same logic, I'll have 2 into 3 into 3 into 3, 54 4-digit numbers. How many 5-digit numbers? 2 into 3 to the power 4, 162 5-digit numbers. And 2 into 3 to the power 5, that is 243. So 486 will be 6-digit numbers. Now you can add this up orally: 415, 500, 640, 690, 700, 14, 18, 20, 26, and 28. So 728 is your correct answer. Next question. And now this is a beautiful question. I hope all of you are familiar with squares. I can give you 2.5 minutes for this question. Let's see how many of you are able to attack this question. Okay, Subodh and Rahul, 728 indeed is the correct answer. You've got 2.5 minutes for the third question. And the third question is actually a fabulous question. Let's see how many of you are able to approach it. For those of you who are here for the first time, एक like ठोक दो भाई YouTube पे अगर हो तो, और शेयर कर दो जहां पे भी शेयर कर सकते हो, जहां पे भी आपको रेलेवेंट लगता है वहां पे. CAT batches at Pathfinder are starting almost every week. Okay, anybody got the answer to this one? Anyone on YouTube also? I don't see anybody who's got an answer on YouTube as well. Anyone who's got the answer here? Okay, so none of you were able to approach this question. Okay, I see one answer. Harsh says 768. Okay, so Harsh, can you explain how? Good, that I guess is the correct answer. Chalo, let me explain it for you. Fine, I'm explaining.
Sir, yeah, okay.
I'll explain. Otherwise, time lag jayega aur koi baat nahi hai. So I'm sure all of you have seen a chessboard. I'm not going to waste a lot of time trying to draw a very neat chessboard. So you have 8 by 8 board, and the cross stands for black, right? The cross stands for all black. And you will appreciate that no two adjacent squares can be black. I'm sure all of you have seen a chessboard. All right. When you see that there are 64 squares, the first thing you need to know is you have to select any one square, right? Let's say we select the white square first. In how many ways can you choose a white square? Obviously, there are 32 white squares. You can choose any one of them in 32C1 or 32 ways. Now, suppose the white square chosen is shaded red, right? So I can't choose a white square in this row. Sorry, I can't choose a black square in this row or in this column. So how many black squares I cannot choose? 1, 2, 3, 4. 1, 2, 3, 4. I can't choose 8 black squares. Correct? So out of 32, I can't choose 8. So I can choose black squares in 24C1 or 24 ways. And see, my task comprises choosing a white square and choosing a black square, and is replaced by an into sign. So 32 into 24, 4 2s are 8, 12, 4 16, 6 carry over 1, 2 3s are 6, 6 and 1, 7. So 768 is your answer. I hope you all are able to follow this, all of you. Okay. If there is no doubt, I can actually go to the next question. And this is another beautiful question. Let's see how many of you are able to approach this question. Try solving this one. And I'll give you 2 minutes for this also. Okay, anybody who's got the answer to this question? So runs code of a delivery, we are a cricket crazy nation. I'm sure everybody knows what is 1, 2, 3, 4, 5, and 6 runs. And they're independent of what happens in other deliveries. This is not actually a CAT question, but I thought this is a good question to be included here today. A batsman played 3 deliveries, then finds the number of possible outcomes that he hit, 2 runs of at least 1 delivery. So to attempt this question, we first have to understand how many cases are there. Case 1, he hits 2 runs in exactly 1 delivery. Right? 1, 2. Or case 2, he hits 2 twos. Or case 3, he hits all the 3 balls for twos. So he hits 3 twos. Now 3 twos is simple. You can get 3 twos only in one way because he is hitting all the 3 balls for 2 runs. So that can happen only in one way. But when he hits 1, 2, so he can hit this 1, 2 on the first ball or on the second ball or on the third ball. So suppose he hits 2 on the first ball. So I get a score in one way because I get 2, which is fixed for ball 1. But for ball 2 and ball 3, I can get every other number except 2. I can get a 1, a single. I can score 3, I can score 4, 5, or 6. So I can have any of the 5 scores for ball 2 and ball 3. Correct? But I could have scored the 2 of ball 2 as well, or of ball 3 as well. So there are 3 such cases. So 75 ways in which he scored a 2 on one ball and something else on other ball. When he has 2 twos, obviously he can have 2 on the first 2 balls, or on the first or third ball, or on the second or third ball. So basically, again, there are 3 cases and you need to select only one ball. So it is ball number 3 in the first case, ball number 2 in the second case, and ball number 1 in the first case. They can be selected in 5 ways. So you can have 15 different scores here, 15 ways of scoring. So what is the total? 75 plus 15 plus 1. All in all, there are 90 ways of getting a score. I hope this part is clear to all of you. Is there any doubt here? Anybody who has a doubt here? If you have a doubt, ask. If you don't have a doubt, give me a thumbs up there. Give me a thumbs up. Okay. Now, the next question I'll have to this next question actually has to be pulled in from the previous page. And you again will have 2 minutes to solve this question. I hope this question, at least some of you will be able to solve. Your time has already started.
So can you zoom it a bit?
Is it okay now?
Yes, sir.
Subodh, I guess that answer is right. Very good. Now, this question is actually based only on the fundamental principle of counting. It doesn't even require any knowledge of permutation or even combination. So for those of you who are here for the first time, welcome once again. And you can join our lives every Friday and Saturday at 6:30 p.m. Yeah. Anyone who's got the answer to this one? So what is the key to answering such question? Anand has a gift voucher with which he can buy one item. So what is given to you is he can either buy one item or he can buy two items. So there are two cases. So either he buys one or he buys two items. And how many categories are there? Formal shirts, there are 10, 15 t-shirts, 10 formal pants, and 15 shorts. Now suppose he decides to buy only one category. So one category means he will either buy a formal shirt or a t-shirt or a formal pant or only a short. So how many formal shirts are there? There are 10 formal shirts, 15 t-shirts, 10 formal pants, and 15 shorts. So 30 plus 20, 50. So he can buy one item in 50 ways. So he can use the voucher by buying only one item in 50 ways. But he can also buy two categories. Now, which two categories? Obviously, since there are four categories, I can have formal shirts and t-shirts, or formal shirts and pants, formal pants, or formal shirts and 15 shorts. So I can have any two categories. So suppose in how many ways I can have two categories? So I can have formal shirts and t-shirts, or I can have formal shirts and formal pants, or I can have formal shirts and shorts, or I can have t-shirts and formal pants, or I can have t-shirts and shorts, or I can have formal pants and shorts. So there are 1, 2, 3, 4, 5, 6. Actually, if you know a bit of combination, you would have realized that there would be 4 C2 cases, which we actually understood by coupling 2 out of these 4 categories, combining. So formal shirts and t-shirts together can be bought in 10 and into 15, that is 150 ways. Formal shirts and formal pants can be bought in 10 into 10, that is 100 ways. Formal shirts and shorts can be bought in 10 into 15, that is 150 ways. Plus t-shirts and shorts can be bought in 15 into 15, that is 225 ways. T-shirts and formal pants can be bought in 150 ways. Plus formal pants and shorts can again be bought in 150 ways. So how many ways you can buy two items? 1, 2, 3, 4, 600, 825, 925. So you can buy two items in 925 ways. So you can use the voucher by buying two items in 925 ways, or you can use the voucher by buying only one item in 50 ways. So 925 plus 50 is all in all 975 ways. So see, it's a beautiful question based only on fundamental principle of counting. There is nothing else which is required to solve this question. Okay, this is another and probably the last question for today.
So
I'll give
in
you
that question, won't we consider identical? Like I considered them identical. Like the
Which
10
one?
formal shirts, I considered them all identical.
Why would you consider 10 formal shirts identical if it is not given that way? If there
Okay,
were 10
sir.
identical formal shirts, it will be given in the question, right?
Okay, sir.
Okay. Next. So once again, 2 minutes for this question and your time starts now. Okay, so both, I guess, छोटी सी गलती कर रहे हो कहीं. You've it's not the exact answer, but you're quite near to the real answer. Okay, how many of you have got it? Anybody who's got the answer, please? Okay, so let me solve it for you. So you have n books, and these n books can be arranged. Raghu has space to arrange 2 books in his cabinet, right? So out of n books, he could arrange only 2 books. So in how many ways can you arrange 2 books out of n books? np2 ways. And np2 is nothing but n into n minus 1. See, np2 is factorial n upon factorial n minus 2, which basically results into n into n minus 1. Now you're told that if he has n ways, he can arrange his cabinet in m ways. So basically np2 is equal to m, or n into n minus 1 is equal to m. Then the second condition is given if he has 5 more books. So if he has n plus 5 books, he can arrange again 2 books out of these n plus 5 books. So n plus 5p2 is equal to 6m, or n plus 5 into n plus 4 is equal to 6 times m. So this is your equation 1, this is your equation 2. So I can equate them by multiplying the first equation by 6. So 6 times n into n minus 1 must be equal to n plus 5 into n plus 4. If there were options, you could have just substituted the options, but you don't have options. So try putting in some simple numbers here. Try putting in, let's say you can't put 1, right? N can't be 1. So if you put n is equal to 2, you get 2, 6 are 12, but on the right hand side, you will get an answer that is greater than 12. Put n is equal to 3, you will get 3, 6 are 18, 2 are 54 on the left hand side, and 8, 7 are 56 on the right hand side. Again, not possible. What about n is equal to 4? 4 3s are 12, 6 are 72, and 9 8s are 72. So n must be equal to 4. So I got it by substitution, by very elementary substitution. And if you're quick with calculations, this is how you should try to approach questions, especially so if options are given. If options are given, we should definitely put in values. But you can even solve this equation. 6n square minus 6n is equal to n square plus 9n plus 20. So you get 5 times n square minus 15n minus 20 is equal to 0. So that is n square minus 3n minus 4 is equal to 0. That is n minus 4 into n plus 1 is equal to 0. N can't be negative, so n has to be equal to 4. So the correct answer to this question must be 4. I hope you're able to follow the solution. Have you been able to follow the solution? All of you? Give me a thumbs up if you're able to follow the solution. All right. So I come to an end of this session right now. Thank you all for joining. And if you join me on YouTube, please note that these live sessions will be there every Friday and every Saturday at 6:30 p.m. Do join me on Fridays and Saturdays. Thank you very much.